Okay, so the next one is question 6. Okay, in question 6 what we're going to have is f of 2. So here's a cubic equation. We're given one of the complex roots, so this means that the complex root is minus 2 plus 3i. Right, and it tells us that it equals 0. We don't actually have to put it in and check that it equals 0. Find the 3 roots of f of z equals 0. So look, all of these are real numbers. It just means that the conjugate is also a root. Okay. Now remember from the last chapter we did z squared minus the sum of the roots, and then minus plus the product. So what we can do here is we can find out it's usually a linear mixed with a quadratic that equals the cubic when you multiply it out. So what we can do is we can find out what the quadratic part is right away, and the quadratic part should divide into the cubic part. So the sum is going to be z squared minus the sum of them, when you add them together, is going to be minus 4z. So it's going to be minus 4z, which is z squared plus 4z, plus the product. So when we multiply these by each other, we're going to get is 4 plus 6i minus 6i minus 9i squared minus 9 minus 1 is plus 9, so we're going to get 13. Okay, so z squared plus 4z plus 13. Okay, and now we're going to divide it in. So we're going to get z cubed minus z squared minus 7z minus 65. Okay, so we're going to divide it all in there. So we're going to have a z, so we're going to have z cubed plus 4z squared plus 13z. Now we're going to take it away. Minus 20z. Okay, and then we're going to look up again, and this time it'll go in the first one went in minus, so this will be minus 5 times, so then we're going to get minus 5z squared minus 20z. This is minus 65, so this one's also going to be minus 65. Then we have to turn them into pluses. Then we get 0. So now we know that z minus 5 is the other factor, and if z minus 5 is the other factor, then z equals 5 is the other root. Okay, and that's question 6 done. Now we're moving on. Okay, so what we have here is 11 and 13. Okay, so what it says is p of z equals z cubed minus iz squared minus 9z plus 9i equals 0. Verify that pi equals 0 and solve pz equals 0. So to verify means that pi definitely equals 0. Z equals I. Replace all z's with i's. Okay, so we're going to get is I cubed minus I times I squared minus 9i plus 9i. So the 9i's cancel. I by I squared is I cubed minus I cubed equals 0. 0 equals 0. That's verified. This means that z minus I is a factor. Okay, and also means z equals I is a root. Now it says solve p of z equals 0. So what we already know is that we already have a root, and because complex roots occur in conjugate pairs, this means that z plus I, change the sign that comes before I, is also a factor. And once I've done that, I can now combine these two factors to make a quadratic equation, to find out a quadratic equation that will divide into the cubic equation. Okay, so what we're going to get is z squared minus the sum of the roots. Sum of the roots is so the two roots are z equals minus I and z equals plus I. So the sum of the roots equals 0. So that's going to be 0z, because I plus minus I is 0, plus the product, which is going to be I times minus I, which is minus I squared, which is plus 1. So z squared plus 1. Z squared plus 1 equals 0 is a quadratic equation. This also means that z squared plus 1 will divide up into this equation here. So what we're going to get is, I'm going to use this equation, the quadratic part, and what we're going to do is we're going to divide it into z cubed minus iz squared minus 9z plus 9i. Okay, it's going to happen is z goes in there, and it's z cubed, and that's iz squared, so it's going to be z cubed plus z squared. Okay, and then we got to take these away. So when we take these away, what we're going to end up getting is, it's going to be, that's minus 1. So it's going to be minus 1 minus I z cubed, sorry, z squared, and then that's going to be minus 9z plus 9i. Now the 9z, 9i can be grouped together because they're both, oh sorry, they can't be grouped together, sorry, my bad. Minus 9z plus 9i. So that is minus 1 minus I squared minus 9z plus 9i. Okay, now continuing on, what we're going to get here is we have to divide this in, and this will divide in divide in minus 1 minus I times. So we're going to end up with minus 1 minus I z squared. Then we got to multiply, we also have to multiply that by no, sorry guys, just excuse me here, I'm just going to start this one from scratch because I made a foolish mistake at the start. Excuse me. What you have to remember is when you're dividing in by z squared plus 1, what you got to remember is the middle part, z squared plus 0z plus 1. Okay, so that's why we're not lining up properly. So what happens here is the first one goes in z times, so we're going to have z cubed plus 0z squared, and then we're just going to have plus z at the end. Now we're going to have minus iz z squared minus 8z plus 9i, and then this has to go in minus I times. Okay, so this one here didn't work out purely for the following reason. I used the conjugate theory, but if you look at the coefficients, all of them aren't real. Okay, so they're not all real. So this just means that z equals I is the only root, and this means I have to divide in z minus I. So it's z minus I is what has to get divided into here, and that's why we were encountering such problems that it didn't work. Okay, so remember, the conjugate theory only works for when all the numbers are real, and all of them weren't real in number 11. Okay, so what we need to do here is we need to just divide in by z minus I. Okay, so it's going to go z squared times, so it's going to be z cubed minus iz squared, which oddly enough goes plus, minus, and then that turns into a plus, that cancels, and then we get minus 9z plus 9i, and that will go in minus 9 times. Okay, and then we get minus 9z plus 9i, and then we take that away, so it turns to plus, that turns into minus, and we get 0. So now we have that it's z minus I multiplied by z squared minus 9, and that makes this equation here. And now we just have to solve z squared minus 9 equals 0, and we're going to get a z plus 3, z minus 3 equal to 0, so z equals plus 3, and z equals minus 3. So we have the 3 roots. So it's z equals I, z equals minus 3, z equals plus 3. Now, if we look at the next part, 11 part 2, it's the same thing as 11 part 1. The coefficients are all the same. So it's a 1, an I, a 9, and a plus 9. But instead of z, we have z minus 2i. But remember, it's what's in the box is the variable, and this variable has already been answered. We've already answered a very similar one. So we're just going to put this new part equal to the answers of the old part. So we're going to get z minus 2i equals minus 3, and z minus 2i equals I. Then solve for each one. Z equals 3 plus 2i, z equals minus 3 plus 2i, and then finally z equals 3i. So those are three answers for question 11. Now question 13 is f of x equals x cubed plus px squared plus x plus q. P and q are element r, this means they're just real numbers. And f of 4 minus I equals 0. Now f of 4 minus I equals 0, it means it satisfies the equation. So f of x equals 0 when x equals 4 minus I. That's basically what that means there. So what we're going to do is we're going to replace all x's with 4 minus I. But before we do that, we're going to just build up. So we're going to find out what x squared is. X squared is 4 minus I with 4 minus I. And what we're going to get there is 16 minus 8i plus I squared. And then we're going to get 15 minus 8i. Once we found out what that is, we're then going to find out what x cubed is. And x cubed is the same thing as x multiplied by x squared, which is going to be 4 minus I multiplied by 15 minus 8i. And once we do that, we're going to get 60 minus 32i minus 15i plus 8i squared. That becomes minus 8. And we're going to end up with 52 minus 47i. Alright guys, so what we have here is the information we need to answer the question. So we're now going to plug it in and make sure that it equals 0, because it says it equals 0. So we're going to get is x cubed, which is my 52 minus 47i. It's 52. Then we're going to have px squared, so it's going to be p multiplied by x squared, which is 15 minus 8i. And then we're going to have plus x, which is plus 4 minus I, and then we're going to have plus q, and this all equals 0. So what's going to happen next is we're going to have 52 minus 47i plus 15p minus 8pi plus 4 minus I plus q equals 0. Now all the real parts equal 0, so we have real, and real. So 52 plus 15p plus 4 plus q equals 0, and then we're going to have 15p plus q equals minus 56. Then we're going to have our imaginary part, I, and I. Remember, it's the coefficients we're after, so it's going to be minus 47 minus 1 minus 8p equals 0, minus 48 equals 8p, p therefore is minus 6. Now we know what p is minus 6, so that's going to turn that into minus 90. Minus 90 plus q is minus 56. Q therefore, when I bring that 90 over the other side, should become 34. So we're looking at minus 6 and 34 for p and q. Oh yeah, so f of x equals 0. So what we get here is basically p is minus 6 and q is 34. So p equals minus 6, q equals 34. So what we now have to do is we have to solve this full thing. Okay, so to solve this full equation. Now luckily for us, all these equations have real numbers, right? So what we're going to have is x cubed minus 6x squared, because px squared plus x is plus x plus 34. Okay, and what we know is because they're real coefficients, we can now use the conjugate. So the conjugate is 4 plus I. Then we can make a quadratic equation out. We can go x squared minus the sum, and the sum is going to be 4 plus I plus 4 minus I is going to be 8x. The product is when we multiply them together. So we're going to get a 4 plus I, 4 minus I. We should get a 16 minus 4i plus 4i, and then we have a minus I squared, which ends up to plus 1, so it's going to be 17. The product is 17 equals 0. And then we got to divide this quadratic equation into the cubic to figure out what are the other roots. And once we've done that, what we're going to get is x goes in there, so it's going to be x cubed minus 8x squared plus 17x, because you're multiplying x by all of this here. Take them away, change the signs, and what you're left with is 2x squared, 2x squared minus 16x plus 34, and then that goes in twice to give us 2x squared minus 16x plus 34. Take them away, and then you get 0. So we know that the other factor is x plus 2, and that equals 0, so therefore x equals minus 2 is the other root. So we have x equals minus 2, x equals 4 plus I, and x equals 4 minus I. Now the next question is an interesting one. It says solve for x, f of x minus 2i. This is the same thing as me asking this, x minus 2i to be cubed plus p times x minus 2i squared plus x minus 2i plus q equals 0. So you can see that's exactly the same equation. P and Q still hold the same values of minus 6 and 34 as they did before, so it's the same thing as this here. Minus 6, and then at the end we have our plus 34. Now we have to solve this equation, and that's basically what this is asking here. But it's the same answer as we had before, except this answer now is represented by x minus 2i. Whatever is in the bracket was the answer. So it's going to be x minus 2i, x minus 2i, and the equal all these numbers here, like minus 2, 4 plus I, and then equals 4 minus I. Then what we can get here is x equals minus 2 plus 2i. Then we have x equals and then 4 minus I, and then the last value is going to be x equals 4 plus 3i, excuse me, because when the 2i goes over the other side it comes plus 2i, and this will also have a plus 2i, which means that it's going to be 4 plus I. And there's our 3 answers for part 2. Okay, so that's number 13 done. We're going to move on. Okay, so this one here is question 16. Let p of z equals z cubed minus 10 plus iz squared plus 29 plus 10iz minus 29. Please note the first thing is that not all the coefficients are real, so therefore the conjugate theory is out the door. Right, it's gone. To determine the real numbers a and b, if pz equals z minus I into z squared plus az plus b. Okay, so what basically this means is that this one multiplied by this one equals this one up here. Okay, so we can do this 2 ways. We can multiply this out and then let it equal the other side and solve it that way, or we can what else could we do? We could try dividing it. We might try both methods. Okay, so the first method I'll do is I'll just multiply this out. So you're going to have z multiplied by z squared plus az plus b, and then we're basically told that z equals I is a root. Okay, but that's not giving us much information. Okay, because this part here is a factor. So now we're going to then multiply minus I into z squared plus az plus b. Then we're going to get z cubed plus az squared plus bz plus iz squared minus aiz minus bi. Now we have to group them in terms of z cubed, which is a standalone, and then we got to get all the squared. So I think that's az squared, iz squared. So it's going to be plus a minus I z squared. And then the next one is the z's, which is bz and aiz. So then it's going to be plus bracket b minus aiz, and then finally at the end minus bi as a standalone. Okay, now this equation here has to match up to the original cubic. So we group this here, then what we say here is that we put it equal to the original cubic, which is z cubed minus 10 plus iz squared, and then plus 29 plus 29 plus 10 iz minus 29i. Now, I suppose what this does is it creates that bi equals minus 29i. So b therefore minus b equals minus 29. B therefore has to equal 29. Now we got to figure out what a is. Okay, and we can see that a is we can see that ai, so a minus I has to be the same thing as, now this is minus 1, so this is technically minus 10 minus I times z, because there's a minus in front of it, so it's minus 10 minus I times z, and the coefficient doesn't need the z there, and then we can figure out that a equals minus 10. So b equals minus 29 and a equals minus 10. Okay, that's actually the quickest way to do it, is to just create the factor and multiply it in. You could also do it via long division, but it'd be quite a difficult ask to get that completely correct. Okay, 17. Factorize z squared minus 5z plus 6, and hence solve the equation z squared minus 5z plus 6. Okay, it's quite an easy one. Just doing the reference number, it's going to be 2 and 3, so z minus 2, z minus 3 equals 0, so z equals 2, and z equals 3. No bother there. Show that this is a factor of the following equation. So to show that it's a factor of the following equation, well, we could do this two ways. Okay, the first way would be like to do long division, and where we could try to put z squared minus 5z plus 6, and we could try and divide it into z cubed plus bracket 4 plus I z squared 1 minus 5i z, and then plus 6 into 1 plus I. You could try that out, but a much quicker way would be to realize that these two guys here are my factors, and if the two d's satisfy this equation, then therefore the two d's are factors. Therefore z minus 2 and z minus 3, sorry, z equals 2 is a root, z equals 3 is a root, therefore z minus 2, z minus 3 are factors, and therefore z squared minus 5z plus 6 is also a factor. Okay, so two different ways of trying it out. So I'm going to try out the z equals 2, z equals 3 method. Z equals 3. So what I'm going to do is, it's going to be 2 cubed plus minus 4 plus I times 2 squared. 2 squared is 4. 2 cubed being 8. So I'm doing it up here. And then I'm going to do times 2. Times 2. And then plus 6 plus 6i. When you multiply it out, you're going to get 8 plus, minus 16i, minus 16 plus 4i plus 2 minus 10i, and plus 6 plus 6i. Then what you're going to get is 8 minus 16 is minus 8, minus 8 plus 8 is 0, 4i plus 6i is 10i, 10i minus 10i is 0. So what you can get here is that z equals 2 is a root. Now we need to do exactly the same thing for 3. So for 3 it's going to be 3 cubed, which is 27, plus 3 squared, which is 9. Just replacing 4 with 9 and 8 with 27. And then it's going to be multiplied by 3, because we're replacing all z's with 3. And it's going to be 6 plus 6i. And then what we can have here is 27 minus 36 plus 9i plus 3 minus 15i, then plus 6 plus 6i. And then what we realise is that 27 minus 36 is minus 9. Minus 9 plus 3 plus 6, 0. Then 9i plus 6i is plus 15i. And then minus 15i equals 0. So z equals 2, z equals 3 are roots. Z minus 2, z minus 3 are factors. Hence, z squared minus 5z plus 6 is also a factor. So the other way of doing a question, question 17, okay, was to, question 17 was to divide it in, and actually dividing in isn't actually as bad as initially thought. So we go z, then we get z cubed minus 5z, and then we get plus 6z. Okay. Now the trick is when doing these is to ignore the z cubed, the z squared, and the z's, okay, and just concentrate on the coefficients that come in front of it. So we have minus 4 plus I plus 5. The minus 4 and the 5 can interact and they become 1. The I is still there. And now the new coefficient is 1 plus I. Now bring down your z squared. The next one is going to be, there's 1 minus 5i, and you're taking away 6. And now you have minus 5 minus 5i. And I'm just going to treat that as minus 5 into 1 plus I. You'll see why in a second. So that's going to become minus 5 into 1 plus I. And then finally the last one is already done for you, 6 into 1 plus I. Now what you notice about each one of these is that they all have 1 plus I. And z goes into 1 plus I z squared, goes in 1 plus I times. Okay? And then all of a sudden we have 1 plus I z squared minus, and then 5 times 1 plus I. Minus 5 times 1 plus I is minus 5, 1 plus I. And then we're going to have 6, 1 plus I, and then you can take them away. What we get is minus, plus, and minus cancels out. And what you're going, everything cancels to come 0. So now you know that your factors are going to be z squared minus 5z plus 6 into z plus 1 plus I. Then when we factorize them, put them equal to 0 to find the roots, we got z equals 3, z equals 2, And now we're going to get z plus 1 plus I equals 0. Bring the 1 plus I over the other side and we get z equals minus 1 minus I. And there's our 3 roots there to this equation. Okay, and that is the answer of part 3, which is here. Find the 3 roots of the equation. And we showed that it was a factor in 2 different ways. I recommend the division method.